Okay, so we were here in 32 page number about the loads. No? Okay, so these were your loads regarding the loads. That means what? For the loads and forces, according to IS code, what your IS code says. Suppose the you have some beam, you have some column, you have some suppose suppose these are your beam, column, and slabs will be there. These will be made up of your what? These are going to be made up of your materials like the concrete, okay, and steel will be there. So now, particularly, suppose if I talk about these particular column, what is the dead load of? That means the load coming from these member column 1, column 2, and then this beam 1. Also, just for an example, I'm showing you these three members, but there will be other members also, as you know, like the slab will be there, the plaster on it will be there, plaster paint will be there, okay, so flooring will be there. So based on these are nothing but your dead loads. These are known as your dead loads. Okay, these are your dead loads. So basically how dead loads we have to, when we are designing a G plus 1 floor, suppose, so before that, when we are designing, we have to calculate also how much load is falling in your, how much load is already present, that is the dead load of the material. So that dead load is taken or calculated by what? By these materials, this one. Suppose for this particular example, if I'm talking, there are how many members? 1, 2, and 3. So the dead load from this plus this plus this, the dead load from these three will be the total dead load of the structure. Because for an example, I told you, right, that these are the only three members in your structure which you want to make now. So the load from these, the load, like you have a self weight, right, like you have a weight, somebody is 50 kg, somebody 60 kg. So like that, this particular member will also have a load. So that means the weight, self weight, or you can say the load. So that is nothing but those loads which cannot be moved, and those are fixed. These loads, once you develop or once you construct your structure, these are going to be resist, that these are going to be fixed. These loads will be fixed. This is not going to decrease, but so to some extent, that means minimum these load is going to be present in your load, in your structure. Okay, so these are known as your dead loads, and to calculate these dead loads, we have to know the unit weight of this member, unit weight of the material, sorry, the materials used inside this column, that means the concrete. Okay, with the help of concrete only we will make concrete steel. So the unit weight of concrete, unit weight of concrete of these. Okay, so all these have combined together will give you the total dead load of your structure. Okay, so this is nothing but your dead load. So, according to IS code, now what the IS code says? The IS code is telling that dead load shall be calculated on the basis of your, on the basis of your unit weight. See, if you sometimes forget, also you have your these things in your IS code only. So when you have your IS code with you, it becomes so easy for you to remember, or if you forget also something. So these are generally known things, but if you, for you people, if you want, then you can just go through your IS code. On the exams also, you can carry with you this IS code, and then you will get to know all the, what happened? Okay, participants waiting. I think meeting is open. So these are dead loads. So according to IS code, IS 456, what does the, how we calculate the dead loads? We calculate on the basis of the unit weight. Right. Then we have the alternatively the dead loads may be calculated on the basis of unit weight of material given in IS 875. In the IS 875 part 1, again you will get the unit weights of different materials. Like suppose concrete, if you are using concretes, steel, for steel sometimes you may use timber. So based on that, based on the material, your unit weight will also change. So based on unit weight you will get your dead loads calculated, right, multiplied by the quantity. So unless more accurate calculations are warranted, the unit weights of plain concrete, yeah, this is important, you see, because since we are using this, what happened? Hello, ma'am, can't hear your voice. Others are able to hear my voice. Is it visible? Sorry, is it audible to others?
Yes, for me.
Yeah, I think the Navam Larson, maybe you have some internet problem. Internet issue might be there. That's why you're not. I'm not audible to you. Maybe that's why. Okay, try to reconnect. Navam Larson. Okay. So now what I was telling, yeah. So since you know this is your IS 456 2000, you it talks about your loads also, how load combinations are to be done in your material or in your structure. So when we are calculating this dead load, okay, when we are calculating this dead load, what we are going to do, obviously we will calculate it for every single design. When you're doing, you will have to know the dead loads. It may be sometimes mentioned in your question, like the dead load for this particular beam size itna itna, or slab size itna is your this much. But if it is not mentioned, this is the very important thing which you should know, that is this one, the unit weight. This you will require in your higher semesters also. Okay, unit weight of plain concrete, this one, and your unit weight of reinforced concrete made with sand and gravel or crushed natural stone aggregate may be taken as 24, this one, 24 kilonewton per meter cube and 25 kilonewton per meter cube. I think you know this thing, and if you don't know, these are already mentioned in your IS code. Okay, so dead load, or the to calculate the dead load, you have to know the basic concrete. Obviously, you are going to use your concrete for your RCC structural member structures. So the dead load, to find out the dead load or to calculate the dead load of that member, you have to know the unit weight of that plain concrete, plain cement concrete, and the reinforced concrete. Reinforced concrete means when you have the reinforcement bars, that is the steel rods or steel bars, you can say, that will be inside the concrete, right? So that is your reinforced concrete. Okay, so what is the unit weight? Your unit weight for the, okay, so your unit weight for the plain concrete is always 24 kilonewton per meter cube. इसको दिमाग में चिपका लो. And the unit weight of the reinforced concrete is 25 kilonewton per meter cube. Okay, this is very basic and very most important thing you need to know.
Why
What?
it is, ma'am, 24?
Hello.
Why
Just
it is
now,
24?
why it is important? Just now I explained you. You was not listening properly, na? What I said you just now, that to calculate your dead load, you will have to know your, because what your IS code says, the dead load shall be calculated on the basis of your unit weight, right? So you have to know your unit weight. Now unit weight को निकालने के लिए, now otherwise you have to do so many to calculate something. तुम एक construction site में है, you want to calculate. Hello sir. Yeah. Okay sir. So what happened is that you need to calculate the dead load of the member, so that in your design procedures you will have to know the dead loads of those members. कितना तुम्हारा, the total structure which you're making, the total structure, how much is the dead load of the total structure, entire structure, that if you know, then obviously you will be you have to design, suppose, a building to carry a load of, that means you know that how many live loads will be there. Live loads in the sense how many members are going to be there, how many floors, you know about the dead loads. When you know about the dead loads, that means the permanent load that is going to be there on your structure. Live load means what? Live load keeps changing. कभी तुम्हारा फर्नीचर आएगा, कभी people will go out, so life loads keep changing, or sometimes wind load, earthquake loads, these wind loads, etc. So they keep on changing, but what doesn't change is your dead load. Dead load is always fixed. Fixed means what? Jab, when you construct something, you will take the material, some quantity of materials, and you are going to make, obviously those materials are going to increase the weight of your structure, है ना? अगर तुम, if you construct a big beam without any reason, like ज़्यादा, you are using more material, you are giving more load to the structure. But if, suppose this suppose this is your beam, hmm, इसका लेंथ सपोज 250 हो गया, and this is another big beam, suppose these two. But you got to know that when you're constructing your structure, this beam, the size of this beam is enough to carry some load which you are thinking that that is going to be coming here, है ना? क्योंकि when you will make the building, you are making a G+1 floor, suppose you are making a G+1 building, you will obviously make the beams, columns, slabs, etc. So obviously the load, or you have to calculate ki how much load is there now already through the materials on the structure. So through the materials, this, like in this particular example I told you, iska weight आएगा, iska load आएगा, iska load आएगा. अगर if you make another floor here, iska beam, column, beam, slab, plaster, paint, everything's load is going to be present permanently there until and unless you renovate your structure, or until and unless your structure fails or some damage happens. Until and unless these things happens, your structure will be permanently like that only. That means iska how much load was here, that much load will be only present for this column, for this beam, and for this another floor. If you want to consider again another floor, iska bhi load will be same, it is not going to change, right? So these are your permanent loads, that are your what? These are your permanent loads, which are nothing but your dead loads. So now, since these are your permanent loads, you obviously know now that ye load to रहेगा ही. These loads will be there in your building. Okay, so that is why if we calculate the dead loads of these members, if we get to know the total dead load of these particular building, suppose if we get to know the total dead load, we can use, or we can know, or we can understand like how much load it is going to take further. Because sometimes your structure may happen that it is becoming too much heavier because of your dead load. Dead load means, like I gave you this example of these two beam. Suppose this beam is smaller than these, obviously you're looking that. But for this particular structure, when you're making this structure, this particular beam is able to carry a load of suppose 100 kilonewton. Hmm. Okay, I'll write here only. Suppose 100 kilonewton. Okay. Now, obviously, this is going to carry more than 100. Suppose 250. Suppose, for an example, this beam will take 250. But you see here, when you're designing the building, you will know the load, probable load that is going to come on the building. Because obviously, हम लोग पहले we don't start making the building, right? You have to calculate. First of all, you have to make the plan means what? How many rooms will be there, how many floors will be there, how many beams will be there, how many columns will be there. Okay, So before making any building or any structure, you will obviously make the plan. Okay, somebody is waiting in the lobby. Okay, so what I was telling, yeah. So when you are making a structure, when you're making this building, obviously you have to. What I was telling, yeah. Suppose you are making this building, you have to. Before making this building, you are not going to simply start making or constructing the building. Before making this building, you have to do the calculations first of all, okay? And those calculations analysis when you do, जब एक बार you calculate and then you find out all the loads, probable loads कितना इतना आएगा अगर हम लोग, if we use, if we are making, suppose for an example this building, if we are making here first floor, second floor, two floors are there and the ground floor is there here, suppose. So what we are getting to know, this is, we are not constructing this building, but before constructing we have generally made a plan that two floors we will make, and for each floor the how many rooms will be there, how many rooms will be there, how many bath toilets, how many kitchens, etc. will be there, how many beams, how many columns will be required for each floor, total floor from ground floor to top floor, how many columns will be required, how many beams will be required, all those things we'll calculate. We'll do the design, that is only call your design, right? We'll calculate how many numbers of beams, columns are required, and based on that, to make this particular building, we are having different number of beams, columns, slabs, etc. And based on this our design, we will be calculating the dead load that is going to come from this our plan. Our plan is to make this building two floor, how many numbers of rooms are there, etc. you have made in your design. So now we are going to calculate how much, for this particular our plan, how much dead load is going to come from these particular plan. So for to calculate that dead load, once we know the dead load, that means the permanent load that is going to come from these our assumed building. So obviously we will know how much stronger your building should be based on this dead load. Okay, again we are going to make it either strong if it is weak, or we are going to make it, we are going to decrease the, and based on your estimation also, when we are designing we'll calculate the loadings. We will find out how much total load is going to come from this building, how much life load can be present, or how much life load is present. Life load, that means furniture, etc., or your movable loads, okay, like human beings, animals, etc. Movable loads, how much is going to come, etc. So once we know this, and also we estimate that kitna kharcha aega, how much it is going to cost us, based on the number of all these members, mattress bhi to chahiye hoga to make this column, particular column. You will need what? You will need concrete. For concrete you will need cement. For then again you will need aggregates. For again you will need water. You will need reinforcement bars, steel bars, etc. तो उसका भी खर्चा है. So much of money is to be invested in this particular. So but maybe you may not have, or your client may not have that much of money. So we'll try to, we'll make the two floors, but how we can decrease the cost. Okay, how we can decrease the cost? In that case you will have, see, this two materials are, this is 100 kilonewton, it can take, this can take 250 kilonewton, right? But 100 kilonewton is suppose sufficient for our building. We have assumed that our 100 kilonewton, if this column, for an example I'm just telling you, like for if this column is strong enough to carry 100 kilonewton, which is maximum for us, we need lesser resistant power from the beam to carry a load of, suppose 60 kilonewton, suppose. But this is able to carry 100 kilonewton, or suppose 80 kilonewton we need to, this beam has to carry, but it can carry 100 kilonewton. So obviously it is more resisting, it has more resisting power, huh? And it can be used in our these structure. But for the same 80 kilonewton, like I said you, what I said you that, yeah, 80 kilonewton. Huh. This green color 80 kilonewton is to be carried by the beam. But beam is carrying, obviously, we have tested and we have found that it can carry 100 kilonewton load. Right. So this is enough for us क्योंकि इसमें material भी कमती लगेगा. But same this, if we use this particular column, sorry, if we use this particular beam, it can carry 250 kilonewton, no doubt. Obviously, is the size of this beam is smaller than this, so obviously this is going to take more load. It can take more load, right? But not necessary for us that we need to carry or we need to put this beam here, because we don't, according to our estimation, this is going to cost us more, because more material will be required in this big, larger beam as compared to this beam. So what we'll do, we'll use this beam. We'll use this beam because हम लोगों को we needed 80 kilonewton to resist, but it can resist 100 kilonewton, so fine for us, no problem. And further 20 more kilonewton of load, it can carry extra load, so no problem to us. So we can use this load here, right? So as compared to this, because if of it will, what will happen, what is the disadvantage if we use this over this beam? That disadvantages is that the structural weight of the load of this particular member is going to increase, and as this load is going to increase when we place it here, the entire structural load will increase, right? So we are not using this. Also, materials that will be required here, that will be required, more materials will be required here, more reinforcement bars will be required here in this particular beam. So obviously you are going to invest more, you have to invest more money as for the same power. That means for 100 kilonewton, which is, it is obviously able to resist 80 kilonewton. So why we need to make this? So we don't need, so for that, so you have to know that how much material you are using, right? बिकॉज हम लोग को देख के पता चल रहा है कि इसमें कम मेटेरियल है, इसमें ज़्यादा मेटेरियल है, एंड मोर द मेटेरियल you use, more the load on the structure will increase, more the cost will increase, economy will go down. Okay, so we have to see everything, and then we have to design the building and we need to proceed further. So your question was that why you need to remember this unit weight of plain concrete and your reinforced concrete. Why we need? Because to know the dead load of these members, suppose I want to know the dead load of this member, I have to know the unit weight of this member. Because once we know the unit weight, dead load is nothing but unit weight into your this size. जितना इसका size होगा, unit weight per meter, मतलब per meter इसका weight कितना है, अगर हम लोगों को पता चल गया, if we know for this particular column 8 meter में, for 1 meter how much is the unit weight, unit weight means the load for 1 meter we know, then if we know the size of these column, if we know the size of this column, then obviously we will know per meter में अगर suppose reinforced concrete, if per meter is 25 kilonewton per meter, suppose per meter if we know unit weight, unit weight means per unit na. So if we know per unit and we know the dimension of the column, obviously we can know the entire load of this. अगर यूनिट वेट पता चल गया तो हम लोगों को ये डायमेंशन भी पता है, कितना लंबा बनाएगा कितना शॉर्ट बनाएगा, तो बेस्ड ऑन दैट इसमें कितना मटेरियल्स आ रहा है जिसकी वजह से कितना लोड बढ़ रहा है, दैट लोड वी कैन कैलकुलेट. टू कैलकुलेट दिस लोड we need to know the unit weight of our plain concrete and the reinforced concrete. Okay, and since for our structure of always we are, yeah, okay then, so since we are going to use always the plain concrete and the reinforced concrete in our structures, हम लोग building बनाए, there are two types of structure, right? You people know that either it can be RCC structure or it can be a steel structure. Okay, others are there, wooden structure, etc. But generally the buildings, the business buildings, the residential buildings, industrial buildings, or any kind of structure, whenever you make those structures, either you will make with steel or with concrete, that means RCC, concrete and steel together, or only steel, है ना? So that is why this IS 456 has given you the most important, which you will always require, that is the for the concrete your unit weight, so that it is easy for you to calculate. क्योंकि हम लोगों को बहुत कैलकुलेशंस करना होगा, we have to do the calculations of each beam. अगर एक बीम का for different sizes of beam, for different sizes of columns, you will have different loads for each particular member. So there will be a lot of calculations on that when you're finding out the dead loads, light loads, etc. So particularly when you're designing a building, so what you need to know, this is important, that's why they have given you, so that you don't need to keep on finding out the unit weight, etc. So this is important for you to remember. कहीं पे भी लगेगा, तुम you want to design something, you want to design in steel girders, you want to design a bridge, you want to design a house, you want to design a shop, anything you want to do, design a staircase, you want to design a slab, you want to design a beam,
For
you want to
ma'am,
design a column, you have to know this to find out the dead load, obviously, huh?
for steel structure, ma'am, it is I think for concrete, na. So how can we calculate the dead load
For
of any
steel structures,
steel structure?
I said you, for steel structure means, suppose you are using steel structure, but for that you will need, sometimes you will also need concrete there in some work. Suppose now if I tell you, uh, for steel structure, suppose above the bridges we use those trusses, those are of steel, that those are called your steel structure. The above the bridge, those steel members you see, those are your steel structures, you say them. But below that there will be abutments of the bridge, so that will be obviously made up of what, concrete and the steel, है ना, concrete and the rods, and sometimes pre-stressed concrete. I had talked in the fourth semester also about the pre-stressed concrete, बहुत समझाया है pre-stress. So pre-stress also, there also you have what, steel tendons are used, huh? So those are used, precast are used in your bridge is what, sometimes your bridge is the bottom portion is concrete made, upper portion is steel made. Sometimes the bottom is steel, upper one is concrete, like that also in some cases. So that's why I said anywhere you may require, wherever you need to calculate the dead loads of any structural member, irrespective of only steel. Okay, if it is only steel, obviously you're not going to use the concrete one. Wherever concrete comes, and that member has concrete in it, you need to find out the dead load. In that case, you have to remember this for your calculation of the dead. Okay, but if only steel is there, then obviously you're not going to use. But steel plus concrete, if you do, then you need to know that particular concrete का, ठीक है? Hello. Yeah, fine. Them.
Ma'am, yes, it's clear.
Huh? Is it okay?
Clear, ma'am. Yeah.
Okay. So that this was, that's why important. चिपका लो दिमाग में ये, सब में लगेगा. तो after that next clause, that is your 9.3, clause number 9.3. What does your clause number 9.3 specify? That imposed load, it talks about basically imposed loads, wind loads, snow loads. It's nothing but kind of light loads. So but इसका भी बहुत सारा conditions हैं. So for that, particularly for different IS codes are there to discuss about these particular loads. Okay. So Imposed loads, wind loads, snow loads shall be assumed in accordance. Like for imposed loads, IS 875 Part 2, wind loads IS 875 Part 3, for snow loads IS 875 Part 4. So you have to follow this code. Okay. Then there are earthquake loads are also there. Sometimes when your earthquake load comes, that means what? That's why earthquake when earthquake comes, it is giving extra load to your structure. So we should make our structures including those loads, assuming those loads like these loads can come sometimes. So based on that, we have to make the structure. So for earthquake force, that's why we need to know about earthquake forces also. And for this, we have IS 1893. Different zones of earthquakes will be there. How we design that, these are there. Okay. So these are different loadings. Now comes your combination of loading. Dead load countering other loads and forces. When dead load counter is the effect due to other loads and forces in such a member joint. Special care should be exercised by the designer to ensure adequate safety. These are simple safety measures which you should take. Okay, so here was your about the dead loads, life loads, wind loads. What were those? We have discussed that in fourth semester. Then earthquake loads. These earthquake loads depend upon the seismic hazard parameters. Each building or structure is assigned a seismic group of design. These are okay. These things you know. I think we'll end the class for now. Almost time. I'll be sharing you the link for your attendance. Okay. I'll share in the group the attendance link. Give the attendance. Okay. Thank you. I'll leave. I'm being called by HOD. Okay. Thank you.
Thank you, ma'am.